Now, I hope I clarified why you need really to focus on the data, and let's start looking at how you actually go and collect this data. Now, the first problem that you need to solve is what I call the bootstrap problem. Let's imagine that you want to build a model that detects solar panels. So you have this problem where in order to train a model that recognizes solar panels, you need to show the model a lot of solar panels. And so you have this kind of circular situation that you need to solve. And so let's see how we solve it. So let's consider, again, the solar panels problem. There are 125 million houses, more or less, in the US, and only between 1% and 2% of them have solar panels. And you can imagine that there are very stark regional differences about the concentration of solar panels, as well as how they look and how the houses look at the vegetation and so on and so forth. So this is how we approach this problem. We start from tabular data like weather data, census, or third-party data that we have access to. And we exploit correlations of these tabular data with what we are looking for, in this case, solar panel. For example, weather data is going to be important. You want to sample a lot from regions where there's a lot of sun. And so by exploiting these kind of correlations, you build an initial set. It's very important for this initial set to be diverse, so not focused all in the same region. For example, you can stratify it by region. And also you want it to be diverse in terms of income, in terms of a lot of other qualities, because you also want to be on the lookout for potential biases in your model. So once you have built this initial data set, you go ahead and you label it. And this data set needs to be of the size that takes you at the beginning of the power region. So it needs to be a decent size, but it doesn't need to be very big. And when you label this data, then you can train an initial model on it. This initial model is going to have okay performances, but not great because it doesn't have a lot of data. But you can use this model to make inference on a much larger sample of locations. And now when you look at this inference, you can select the examples where the model is the most uncertain on. And these are going to be the examples where the model can learn the most from. And so you're going to select these uncertain examples to label next and to increase the size of your data set. And so you go ahead and you label these data, and then you retrain the model, and you repeat this loop until you get to a satisfactory performance, and that's going to be your final model. And this approach is called active learning.
If you enjoyed this video, check out the extended full talk on grmds.org. Use the link in the description to take advantage of a complimentary 1-month premium membership to our data science ecosystem, where you can access online courses, webinars, datasets, workflow collections, and much more. Be sure to like and subscribe if you enjoyed this video for more content like this.